Hey guys, Mr. Mackey here. Now, yesterday I was showing you how to draw linear graphs with the equations that we worked on Tuesday's video. And for the challenge I set you last night, I wanted you to draw the graph that has the equation y equals 5 minus 2x. Now to do this we need to find the coordinates first, which I've already done. Let's go and see how this graph should look like. Let's get on with it. So, what I've done before this video, just to save a bit of time, is I found the y coordinates and I labelled them as the coordinates. All we have to do now is place the coordinates in this graph and then join them together. So remember, the x-axis is along the corridor and the y-axis is up the stairs. Now, because people have told me from my previous video that the x ones were a little bit too together, I spaced them out because there's less to worry about, whereas the y's were going up to 13 and I didn't want to waste too much of my paper. So what I always do is I start with the 0, so we go along the corridor 0, but we're going up the stairs 5, so we go here. The next one we go along the corridor once, but up the stairs 3 times. Along the corridor twice, up the stairs once. Along the corridor 3 times, but we're going down the stairs once. Along the corridor 4 times, down the stairs 3 times. So here we go. And that's the first set done. So all these can be ticked off. Now let's work out the negative. So along the corridor -1, but up the stairs 7. Along the corridor -2, up the stairs to 9. Along the corridor to -3, up the stairs to 11. Along the corridor -4, up the stairs to 13. Now that we've got this line, we can now join them together. And remember, graphs like this go on forever. So you only get the full marks if you drew the line until you run out of paper. And that's how you do it. That is how you draw a linear graph for 5 minus 2x. So, now that we know how to draw these linear graphs, the next thing we're going to do is work out what I mentioned yesterday. Now, yesterday I mentioned in the video what the gradient was. Does anyone know what it is? Well, today we're going to find out. And for this, we're going to go back upstairs to the whiteboard and I'm going to show you how to find the gradient and the y-intercept in equations of lines. Let's do this. Good to be back. Now, this is what the typical equation of a linear graph looks like. Because remember, we have always a number in front of the x and we also have a number at the end, which is in this case y equals mx plus c. What this basically means is the typical sort of structure of how a linear equation would look. But what does the m mean? Well, the m means the gradient. The gradient. And a gradient is how steep our line is. So if the gradient's bigger, the line's going to be very, very, very steep. If the gradient's quite small, the line's going to be not as steep. Now the C represents the y-intercept. The y-intercept is where the line passes through the y-axis. So remember, the x-axis is along the corridor, the y-axis is up the stairs, the y-intercept is where on those stairs the line will go through. Because linear graphs go on forever, they always have to go through a y-intercept. They always have to. Because if they don't, they're not linear, if that makes sense. So what we're going to do today is I'm going to show you various examples of linear graphs, and I'm going to show you how to find the gradient and the y-intercept from them. Let's get on with it. So I have the equation y equals 3x plus 5. What's the gradient and what's the y-intercept? Well, the gradient is the number that's always in front of the x, which in this case is 3. So our gradient is 3. Now the y-intercept is the number that follows, which in this case is 5. But we don't say 5. How we actually write it is 0 and 5. Why? Because that is the coordinate of the y-axis where the line will cut through. So the actual y-intercept is the coordinate that our linear graph will go through on the y-axis. Gradient we can leave as just 3, but the y-intercept we have to write as that. Does that make sense? What about this one? Y equals 2x minus 9. Well, the gradient is the number in front of the x, which in this case is 2. What about a y-intercept? Well, a y-intercept is not 9, it's negative 9. So how we write our y-intercept is 0, negative 9. Because it's not positive, because it's got a negative sign next to it. What about this one? Y equals 8 minus 5x. Well, the gradient is the number that goes in front of the x, which is negative 5. So the gradient is negative 5. The y-intercept is the number that is also in this problem, but is not linked to the x whatsoever. And in this case, it's 8. So our y-intercept is 0 and 8. They don't even have to be in the same order every time. As long as you know that the coefficient, the number in front of the x, is the gradient, and any numbers that go on from that is the y-intercept, that's all you need to know. Now, what about this equation? Y minus 4x equals 6. Now, many of you will automatically say that the gradient in this is negative 4 because it has a negative less than the number in front of the x. The one thing you need to know is whenever you're doing these kind of problems, you have to make sure that the linear equation looks identical to this one, which means that y has to be on one side and everything else has to be on the other. So for this, we're going to have to move our negative 4x to the other side of this problem. How are we going to do that? Well, don't you remember the balancing method we did in Algebra Week? So, instead of minusing 4x, we have to add 4x on both sides. And once we've added 4x on both sides, we will end up with y equals 4x plus 6. That's more like it, isn't it? So the gradient is 4, and the y-intercept is 0 to 6. You need to remember you have to make it identical to the example up here. This is probably one of the most important equations you need to know. So you need to know this off by heart. Now this is a fairly quick lesson today because all I'm doing is I'm showing you how to find the gradient and the y-intercept in these equations. Because in tomorrow's video we're going to be using that information to draw lines without using those tables with just the equations we've been given. Now these are 3 examples of equations where people will definitely get thrown up on. They may not understand how to find each of the gradients and the y-intercepts on these. So this is your challenge for today. Find for me the gradients and the y-intercepts of these 3 problems. Some of them you might need to do more work than others. Some of them you may not be sure about. Just try your best. All I will say is that there's always a y-intercept. So even if you put there's no y-intercept, you're wrong. There will always be a y-intercept. You just need to think a bit more outside the box. And secondly, for this one, you have to make it look identical to this. So you might have to do more than just moving the x's onto the other side. What do you think I mean by that? Good luck with these 3 problems. Hope you do well, and I'm looking forward to seeing it tomorrow. Good luck, guys.